Radio is the technology of using radio waves to carry information, such as sound, by systematically modulating some property of electromagnetic energy waves transmitted through space, such as their amplitude, frequency, phase, or pulse width. When radio waves strike an electrical conductor, the oscillating fields induce an alternating current in the conductor. The information in the waves can be extracted and transformed back into its original form. Radio systems need a transmitter to modulate some property of the energy produced to impress a signal on it. For example, using amplitude modulation or angle modulation. Radio systems also need an antenna to convert electric currents into radio waves, and vice versa. An antenna can be used for both transmitting and receiving. The electrical resonance of tuned circuits in radios allow individual stations to be selected. The electromagnetic wave is intercepted by a tuned receiving antenna. A radio receiver receives its input from an antenna and converts it into a form usable for the consumer, such as sound, pictures, digital data, measurement values, navigational positions, etc. Radio frequencies occupy the range from 3 kHz to 300 GHz, although commercially important uses of radio use only a small part of the spectrum. A radio communication system sends signals by radio. The radio equipment involved in communication systems includes a transmitter and a receiver, each having an antenna and appropriate terminal equipment such as a microphone at the transmitter and a loudspeaker at the receiver in the case of a voice communication system. Etymology. The term radio is derived from the Latin word radius, meaning spoke of a wheel, beam of light, ray. It was first applied to communications in 1881 when, at the suggestion of French scientist Ernest Mercader, Alexander Graham Bell adopted radiophone as an alternate name for his photophoned optical transmission system. However, this invention would not be widely adopted. Following Heinrich Hertz's establishment of the existence of electromagnetic radiation in the late 1880s, a variety of terms were initially used for the phenomenon, with early descriptions of the radiation itself including Hertzian waves, electric waves, and ether waves, while phrases describing its use in communications included spark telegraphy, space telegraphy, aerography, and, eventually and most commonly, wireless telegraphy. However, wireless included a broad variety of related electronic technologies, including electrostatic induction, electromagnetic induction, and aquatic and earth conduction, so there was a need for a more precise term referring exclusively to electromagnetic radiation. The first use of radio in conjunction with electromagnetic radiation appears to have been by French physicist Edouard Branly, who in 1890 developed a version of a coherent receiver he called a radio conductor. The radio prefix was later used to form additional descriptive compound and hyphenated words, especially in Europe. For example, in early 1898 the British publication The Practical Engineer included a reference to the radio telegraph and radio telegraphy, while the French text of both the 1903 and 1906 Berlin Radio Telegraphic Conventions includes the phrases radiotelegraphic and radiotelegrams. The use of radio as a standalone word dates back to at least December 30, 1904, when instructions issued by the British Post Office for transmitting telegrams specified that the word radio is sent in the service instructions. This practice was universally adopted, and the word radio introduced internationally by the 1906 Berlin Radio Telegraphic Convention, which included a service regulation specifying that radio telegrams shall show in the preamble that the service is radio. The switch to radio in place of wireless took place slowly and unevenly in the English-speaking world. Lee De Forest helped popularize the new word in the United States. In early 1907 he founded the De Forest Radio Telephone Company, and his letter in the June 22, 1907 Electrical World about the need for legal restrictions warned that radio chaos will certainly be the result until such stringent regulation is enforced. The United States Navy would also play a role, although its translation of the 1906 Berlin Convention used the terms wireless telegraph and wireless telegram. By 1912 it began to promote the use of radio instead. The term started to become preferred by the general public in the 1920s with the introduction of broadcasting. British Commonwealth countries continued to commonly use the term wireless until the mid-20th century, though the magazine of the British Broadcasting Corporation in the UK has been called Radio Times since its founding in the early 1920s. In recent years the more general term wireless has gained renewed popularity, even for devices using electromagnetic radiation, through the rapid growth of short-range computer networking, e.g., wireless local area network, Wi-Fi, and Bluetooth, as well as mobile telephony, e.g., GSM and UMTS cell phones. Today, the term radio specifies the transceiver device, a chip, whereas wireless refers to the lack of physical connections. Thus equipment employs embedded radio transceivers, but operates as wireless devices over wireless sensor networks. Processes. Radio systems used for communication have the following elements. With more than 100 years of development, each process is implemented by a wide range of methods, specialized for different communications purposes. Transmitter and modulation. Each system contains a transmitter. This consists of a source of electrical energy, producing alternating current of a desired frequency of oscillation. The transmitter contains a system to modulate some property of the energy produced to impress a signal on it. This modulation might be as simple as turning the energy on and off, or altering more subtle properties such as amplitude, frequency, phase, or combinations of these properties. The transmitter sends the modulated electrical energy to a tuned resonant antenna. This structure converts the rapidly changing alternating current into an electromagnetic wave that can move through free space. Amplitude modulation of the carrier wave works by varying the strength of the transmitted signal in proportion to the information being sent. For example, changes in the signal strength can be used to reflect the sounds to be reproduced by a speaker, or to specify the light intensity of television pixels. It was the method used for the first audio-radio transmissions, and remains in use today. AM is often used to refer to the medium-wave broadcast band, but it is used in various radio telephone services such as the citizen band, amateur radio, and especially in aviation, due to its ability to be received under very weak signal conditions and its immunity to capture effect, allowing more than one signal to be heard simultaneously. Frequency modulation varies the frequency of the carrier. The instantaneous frequency of the carrier is directly proportional to the instantaneous value of the input signal. FM has the capture effect, whereby a receiver only receives the strongest signal, even when others are present. Digital data can be sent by shifting the carrier's frequency among a set of discrete values, a technique known as frequency shift keying. FM is commonly used at very high-frequency radio frequencies for high-fidelity broadcasts of music and speech. Analog TV sound is also broadcast using FM. Angle modulation alters the instantaneous phase of the carrier wave to transmit of signal. It may be either FM or phase modulation. Antenna. An antenna is an electrical device which converts electric currents into radio waves, and vice versa. It is usually used with a radio transmitter or radio receiver. In transmission, a radio transmitter supplies an electric current oscillating at radio frequency to the antenna's terminals, and the antenna radiates the energy from the current as electromagnetic waves. In reception, an antenna intercepts some of the power of an electromagnetic wave in order to produce a tiny voltage at its terminals, that is applied to a receiver to be amplified. Some antennas can be used for both transmitting and receiving, even simultaneously, depending on the connected equipment. Propagation. Once generated, electromagnetic waves travel through space either directly or have the path altered by reflection, refraction or diffraction. The intensity of the waves diminishes due to geometric dispersion. Some energy may also be absorbed by the intervening medium in some cases. Noise will generally alter the desired signal. This electromagnetic interference comes from natural sources, as well as from artificial sources such as other transmitters and accidental radiators. Noise is also produced at every step due to the inherent properties of the devices used. If the magnitude of the noise is large enough, the desired signal will no longer be discernible. The signal-to-noise ratio is the fundamental limit to the range of radio communications. Resonance. Electrical resonance of tuned circuits in radios allow individual stations to be selected. A resonant circuit will respond strongly to a particular frequency, and much less to differing frequencies. This allows the radio receiver to discriminate between multiple signals differing in frequency. Receiver and demodulation. The electromagnetic wave is intercepted by a tuned receiving antenna. This structure captures some of the energy of the wave and returns it to the form of oscillating electrical currents. At the receiver, these currents are demodulated, which is conversion to a usable signal formed by a detector subsystem. The receiver is tuned to respond preferentially to the desired signals and reject undesired signals. Early radio systems relied entirely on the energy collected by an antenna to produce signals for the operator. Radio became more useful after the invention of electronic devices such as the vacuum tube and later the transistor, which made it possible to amplify weak signals. Today radio systems are used for applications from walkie-talkie children's toys to the control of space vehicles, as well as for broadcasting, and many other applications. A radio receiver receives its input from an antenna, uses electronic filters to separate a wanted radio signal from all other signals picked up by this antenna, amplifies it to a level suitable for further processing, and finally converts through demodulation and decoding the signal into a form usable for the consumer, such as sound, pictures, digital data, measurement values, navigational positions, etc. Radio band. Radio frequencies occupy the range from a 3 kHz to 300 GHz. Although commercially important uses of radio use only a small part of the spectrum, other types of electromagnetic radiation, with frequencies above the RF range, are infrared, visible light, ultraviolet, X-rays and gamma rays. Since the energy of an individual photon of radio frequency is too low to remove an electron from an atom, radio waves are classified as non-ionizing radiation. Communication systems. A radio communication system sends signals by radio. Types of radio communication systems deployed depend on technology, standards, regulations, radio spectrum allocation, user requirements, service positioning, and investment. The radio equipment involved in communication systems includes a transmitter and a receiver, each having an antenna and appropriate terminal equipment such as a microphone, microphone at the transmitter and a loudspeaker at the receiver. In the case of a voice communication system, the power consumed in a transmitting station varies depending on the distance of communication and the transmission conditions. The power received at the receiving station is usually only a tiny fraction of the transmitter's output, since communication depends on receiving the information, not the energy, that was transmitted. Classical radio communication systems use frequency division multiplexing as a strategy to split up and share the available radio frequency bandwidth for use by different parties' communications concurrently. Modern radio communication systems include those that divide up a radio frequency band by time division multiplexing and code division multiplexing, as alternatives to the classical FDM strategy. These systems offer different trade-offs in supporting multiple uses. Beyond the FDM strategy that was ideal for broadcast radio but less so for applications such as mobile telephony, a radio communication system may send information only one way. For example, in broadcasting, a single transmitter sends signals to many receivers. Two stations may take turns sending and receiving, using a single radio frequency. This is called simplex. By using two radio frequencies, two stations may continuously and concurrently send and receive signals. This is called duplex operation. History. In 1864, James Clerk Maxwell showed mathematically that electromagnetic waves could propagate through free space. The effects of electromagnetic waves were actually observed before and after Maxwell's work by many inventors and experimenters, including Luigi Galvani, Peter Samuel Monk, Joseph Henry, Samuel Alfred Varley, Edwin Houston, Elihu Thomson, Thomas Edison, and David Edward Hughes. Edison gave the effect the name etheric force, and Hughes detected a spark impulse up to 500 yards with a portable receiver, but none could identify what caused the phenomenon, and it was usually written off as electromagnetic induction. In 1886, Heinrich Rudolf Hertz noticed the same sparking phenomenon and, in published experiments, was able to demonstrate the existence of electromagnetic waves in an experiment confirming Maxwell's theory of electromagnetism. The discovery of these Hertzian waves prompted many experiments by physicists. An August 1894 lecture by the British physicist Oliver Lodge, where he transmitted and received Hertzian waves at distances up to 50 meters, was followed up a year later with experiments by Indian physicist Jagadish Bose in radio microwave optics and construction of a radio-based lightning detector by Russian physicist Alexander Stepanovich Popov. Starting in late 1894, Guglielmo Marconi began pursuing the idea of building a wireless telegraphy system based on Hertzian waves. Marconi gained a patent on the system in 1896 and developed it into a commercial communication system over the next few years. Early 20th century radio systems transmitted messages by continuous wavecode only. Early attempts at developing a system of amplitude modulation for voice and music were demonstrated in 1900 and 1906, but had little success. World War I accelerated the development of radio for military communications, and in this era the first vacuum tubes were applied to radio transmitters and receivers. Electronic amplification was a key development in changing radio from an experimental practice by experts into a home appliance. After the war, commercial radio broadcasting began in the 1920s and became an important mass medium for entertainment and news. World War II again accelerated development of radio for the wartime purposes of aircraft and land communication, radio navigation and radar. After the war, the experiments in television that had been interrupted were resumed, and it also became an important home entertainment medium.